Hi, everyone. Let's talk about section 0.6, various types of expressions in X. Before, we classified numbers. Now, let's classify expressions in X, let's say. All right. First of all, what's a polynomial? These are things that you studied back in your Algebra 1 and 2 classes. Here's the bad news. The formal definition for a polynomial looks like this. And seriously, in the Math 200 level class, you better be prepared to write a form like that. But let's come back to this later. Let's do some examples first, okay? Let's do that. All right. All right. So let's do an example first. Example. This is an example of a polynomial. Okay, and let's try to remember the various terminology here. All right, so here's a polynomial. 4x to the third minus 5 halves x squared plus 1. Notice that the exponents here, I'll make some comments here. Notice that the exponents here are non-negative integers. Non-negative integers. The exponents on x, I should say. Right. It's okay to have a messed up number like pi, all right? But you cannot have x to the pi. You can have pi, but not x to the pi. All right, so the exponents on x, the 3, the 2, there's actually a power of x here. X to the what is 1. X to the what is 1. X to the 0 is 1. So you could think of 1 as 1x to the 0. The exponents on x are all non-negative integers. The highest exponent on x, is the degree. Okay, assuming that's being written in this descending powers form, which I indicate over here. I'm assuming the polynomial is written in this descending powers form. All right, but as it stands, the highest exponent on x indicates that's a third degree polynomial. All right. The leading coefficient is the 4 here. Do that in brown. The leading coefficient is going to be the 4 here. Now, the degree and the leading coefficient are both obtained from this here, which is called the leading term. The leading term is 4x to the third. Okay. It's the term containing the highest power of x, the x to the highest exponent, the degree. 4 is the leading coefficient, 3 is the degree. So the leading term is very powerful. If you tell me the leading term for a polynomial, I already know a lot about the polynomial. We'll see that in chapter 2. Okay. And then on the other hand, here's this little guy here. Constant term is 1. If you don't see a constant term, okay, something that a number without an x to an x or an x squared next to it, if you don't see a constant term, then it's 0. So if we didn't have the plus 1, the constant term would be 0. All right. Now, it doesn't matter what order you order the terms in. This is descending powers form up here. But you can reorder the terms, and you'd still have the characteristics that it will be a third degree polynomial in x. 4 is still the leading coefficient. But be careful, because if I ask you, what's the leading coefficient on this polynomial? The leading coefficient is still the 4. The leading coefficient is still the 4. 4x cubed is still the leading term, right? Even though it's written at the right end here. That's why descending powers is often more convenient, because then you can quickly tell the leading term is the guy on the left. All right. The polynomial fits this ugly form here, where n is the degree. So I'm doing this bit by bit, right? I'm gonna blow this up a little bit. Okay, in blue, the degree up here was 3, all right? Degree equals n, which is 3 in our example. All right. Now, here's the thing. So this is of this form. where the leading term, 4x cubed, put that in dark brown, all right? The leading term, 4x cubed, is a sub n x to the n, all right? A sub n is the leading coefficient, that's in light brown, okay? 4 is the leading coefficient, that's this a sub n guy. Remember, n is the degree. So the coefficients are a sub 0, a sub 1, a sub 2, and so on up through, in this case, a sub 3. That's going to be the leading coefficient. It's the coefficient for the x to the third term. All right. And then the constant term 1, that was in purple. The constant term 1 is going to be a sub 0. Because remember, you can think of 1 as 1x to the 0. So it's the 0th degree term. So this polynomial, if you want to expand it out, you could write it as, so here I'm literally expanding it out. I'm writing it out, and I'm indicating the missing term, 0x. There's no x term in here, so the corresponding coefficient is 0. I'm putting in the missing term. Sometimes we do want to indicate the missing term. All right. So here's the polynomial written in descending powers. All right. It follows this format. Follows this format. Where the coefficients are, let's read off the coefficients. In fact, we might want to go in reverse here. We might want to go in reverse. All right, so the constant term, hold on. The constant term, the 1 here, is a sub 0, okay? It does count as a coefficient. Now, a sub 1, okay, is going to be the coefficient on x. So here's this term, 0x. The coefficient on the x term is 0. That's the value for a sub 1. A sub 1 is 0. This is like the data sheet for this polynomial. If I know that's a polynomial in x, I know the degree, I know these coefficients, I'm set. A sub 2, what is the coefficient on x squared? Be careful. What is the coefficient on x squared? It's negative 5/2. So a sub 2 is negative 5/2. In the generic form, we put plus signs here so that if the coefficient is positive, well, we see plus. If the coefficient is negative, we see minus in the final form. The leading coefficient, I always put this in brown, I guess, a light brown. The leading coefficient, the 4 here, that's a sub 3. In general, the leading coefficient is a sub n. If I had a 10th degree polynomial, then the leading coefficient would be a sub 10. In this case, it's a 3rd degree polynomial. The leading coefficient is a sub 3. All right, so that's the data sheet of coefficients for this polynomial in x. So if I have a polynomial in x and you care, then if I tell you what a sub 3, a sub 2, a sub 1, and a sub 0 are, you're set. You can construct the polynomial and make it look a little bit nicer, like up here, without all the marks. Basically zap the missing term. So a constant like 1 or 7, these guys are themselves polynomial, but they're 0th degree. You can think of 7 as 7x to the 0. It counts as a 0th degree polynomial, albeit with just one term. The guy up here has 3 terms, as it's written, 1, 2, 3. You don't count the missing terms with 0 coefficients. The key terms are separated. Okay, the number of terms are indicated by the number of primary plus signs and minus signs plus 1, right? So here we have an implied plus sign in front. We have one term. I should erase all this. There's so much going on here. All right, so we have an implied plus sign here, all right? We have 3 terms. The 3 terms are 4x cubed, negative 5x squared, and positive 1. So 3 terms. Okay. And each term corresponds to a primary plus or minus sign in front. There's an implied positive sign in front here. All right. So what's more general than polynomials? All right. We'll talk about that later on. Now, I mentioned the number of terms. What are some things we care about with a polynomial? All right. So if I have a polynomial and you care, all right, then what are some things that you might care about the polynomial? You might care about its degree, the highest exponent on x, and you might care about the number of terms. By the way, when I went over this stuff, I was basically going over the definition of a polynomial, all right? So in fact, I'll go over this before I go on to the categories, right? So what's a polynomial? Let n be a non-negative integer. That's going to be the degree. An nth degree polynomial in x, written in descending powers of x, has the following general form. This over here, where the leading coefficient, by definition, cannot be 0. The a sub 1, a sub 2, etc., these guys are the coefficients. They're the numbers in front of the powers of x. And we're going to have real numbers as coefficients, although later on, in very high math, they can be imaginary. Again, the leading coefficient must be non-zero, although the others could be, right? I mean, maybe 4 is the leading coefficient, and if all these other coefficients are 0, then 4x cubed is your only term. You have a one-term polynomial called a monomial. Okay, the last guy is a constant term. If you don't see one, it's 0, right? Right. Only non-negative integers as exponents. So we went over the definition of a polynomial and the anatomy. What are ways of categorizing polynomials? Well, we can categorize them by degree. Now, 0 itself is a polynomial with no degree. He's too weird, all right? But a non-zero constant like 1, 2, 3, 7, pi, your SSN, negative 12 thirds, well, negative 12 fifths, okay? The non-zero constants, they have degree 0, because you can think of 7, for example, as 7x to the 0. A first degree polynomial will be linear, like 3x plus 4. Second degree, quadratic, like 5x squared minus x plus 1. Remember, the degree corresponds to the highest exponent on x in the descending powers form. So don't have any messed up things like all squared or something like that, because then that might make the degree more confusing. Here's an example of a cubic. See, the highest exponent on x is a 3 in the descending powers form. And then these are more rare. 4th degree is quartic, 5th degree is quintic. Okay, but these are good terms to know. Constant, linear, quadratic, and cubic, which will tell you the degree of the polynomial. Also, categorizing polynomials by number of terms. So a polynomial with just one term, like x to the 5th. So the leading coefficient is the only non-zero coefficient. That's called a monomial, like a monocle, which rich people used to wear. That's my idea of a monocle. All right, a binomial, 2 terms, like a bicycle has 2 wheels. This is like a pi bicycle. Oh, wow. That's why I'm not an art major. All right, so a 2-term polynomial is a binomial. It can be of any degree, except maybe 0, because that's like just a constant. Okay, a 3-term polynomial is a trinomial. 5x squared minus x plus 1. So this here, I call a QT. That's not an official term, but that here, this guy here is an example of a QT. Why? What degree is this? 5x squared minus x plus 1. The degree is 2. Therefore, it's called a quadratic polynomial, or just a quadratic. A QT is a quadratic based on the degree. How many terms? 3 terms. Quadratic trinomial. Like a tricycle has 3 wheels. I'm not going to draw a tricycle. All right. Quadratic trinomial. And what do we do with quadratic trinomials? Guys like these, back in your Algebra 1 class, what was the frustrating thing you did with these guys? You factored them. Maybe using guessing or something like that. We're going to factor quadratic trinomials and review that. Okay. Now, before we go on to the more general expressions, a lot of people forget how to square binomials. The square of a plus b is not. I repeat, is not. I better put this in red. Sorry. Okay, let's get in here. There we go. Not. The square of a plus b, am I making my point? The square of a plus b is not a squared plus b squared. So all that effort. The square of a plus b is not a squared plus b squared. It's this thing here. All right. So if you take a plus b, what does squaring this binomial mean? Well, you take the square of something, you take this guy, and you multiply by itself. And then you apply what four-letter acronym? It's really the distributive property, but you apply the FOIL method. And you get a times a is a squared. Over here, b times b is b squared. But don't forget, all right, it's true that a times a, the product of the first terms, is a squared. It's true that b times b, the product of the last terms, the L, is b squared. But don't forget, the product of the outer terms is ab, all right? O, I for inner, the product of the inner terms, ba. But these are equivalent terms, right? ab plus ba is 2ab. And a lot of students forget that 2ab. The square of a plus b is not a squared plus b squared. It's this thing. It's this trinomial. Lots of memes for this. First of all, if you don't see why that is, look at this. Look at this square here. Side length a plus b, side length a plus b, all right? The area of this big square is the sum of the areas of these little squares and rectangles. The area of the yellow rectangle, a times a is a squared. The area of the green rectangle, b times b is b squared. The blue, okay, b times b is b squared. That's the area of the green square here. The blue rectangle here, a times b is ab. The blue rectangle here, b times a is ba or ab. The total area of the big square is a squared plus 2ab plus b squared. You can extend this idea to 3 dimensions, where you get 4 terms in the expansion. 4 dimensions, raised to the 4th power. That's called a tesseract, like in A Wrinkle in Time. You get 5 terms in the expansion. In chapter 9, we're going to talk about the binomial theorem, where we're going to take a plus b, maybe to the 10th, and find a very quick way of writing it out, or a pretty quick way of writing it out. See here, the square of a plus b. Don't forget the 2 skinny rectangles here, right? The 2ab there. Some more memes. I got these from, I guess, Facebook or somewhere. Read it. And this one here. And folks, that's not blood. I had a student who said, hey, Ken, is that blood? No, it's not blood. It's a cloud. Please, it's not blood. It's a cloud. She's not that vicious. All right. So the square of a plus b, it's not a squared plus b squared. What is it? It's a squared plus 2ab. Don't forget those little rectangles, right? Don't forget the little rectangles from this guy over here, right? Okay, over here. Remember, in the FOIL method, product of the first terms, a times a is a squared, that's fine. L, product of the last terms, b times b is b squared. But don't forget, product of the outer terms, a times b. Product of the inner terms, b times a. Here's FOIL, right? A times a is a squared, that's the F. B times b is b squared, that's the L. Product of the first terms, product of the last terms. But don't forget, in bright red, product of the outer terms, a times b. Product of the inner terms, b times a. That's a 2ab. And then likewise, the square of a minus b is a squared minus 2ab plus b squared. These 2 guys are referred to as PSTs. For what? Do you remember? Perfect square, whoops, trinomials. Perfect square trinomials. They factor. Factoring is when you reverse the multiplication, reverse the squaring. Factoring is going this way, make it more in this case, make it more compact. All right. factoring it like this as a product or a square here. All right. The perfect square trinomials. So the square of x plus 3 is x squared, right? We also have the 9. The square of 3 is 9. But don't forget, 2ab, twice the product of the two terms. All right? So what's that middle term here? Okay, don't miss the middle term. Don't miss the middle term. How do you get the 6x? All right, it's twice x times 3. It's twice the product of the two terms. Twice x times 3 is 6x, the 2ab term, all right? Or in this case, it's the negative 2ab term if you have a minus sign there. Right? All right. Next, we're going to talk about more general expressions.